Right, good evening, my dear students. Good evening, Chilani. Good evening, all of you. Good evening, my dear students. Please join fast. Join fast. My dear students, join fast. Just we had 30 minutes of session. Very, very useful foundation course. Very good evening, Vasu. Very good evening. Join fast. లైక్ చేసి షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. అన్అకాడమీ గేట్ తెలుగు ఛానల్ సబ్స్క్రైబ్ చేసుకోండి. ఒక్కొక్కరు 10 మెంబర్స్ చేత సబ్స్క్రైబ్ చేయించండి. టేక్ ఇట్ యాజ్ ఎ సింపుల్ రెస్పాన్సిబిలిటీ. జాయిన్ ఫాస్ట్. మై డియర్ స్టూడెంట్స్, జాయిన్ ఫాస్ట్. Right. Let me start with my introduction. Myself, Venkat Krishna. My qualification is Computer Science, MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience in training the students in GATE in 3 different subjects: design and analysis of algorithms, engineering mathematics, and discrete mathematics. Right. Welcome to Unacademy. Unacademy is the best online platform in India for all competitive examinations. Let us see why it is best, in terms of what it is best, what type of subscriptions are there, what will be the duration of subscription, what will be the cost, and what will be the available features in available subscriptions. Let's see. In Unacademy, you will be having 2 types of subscriptions. So one is a plus subscription, another one is iconic subscription. What a student gets advantage if he or she takes subscription in plus, you will be having 4 features. One is live classes, test series will be there, structured schedule, and unlimited practice. So let me tell you what you mean by unlimited practice. DPP. Daily practicing problems. Daily practicing problems. Every day you can find new problems. Find new problems. Okay. So when you go for DPP, you will get a lot of confidence. That is the best way to clear GATE examination or engineering service examination. Let's come to iconic. In case of iconic, you will be having 4 features. One feature is personal coach. One personal coach will be appointed to every student. Study planner will be there. You will be having many questions and answers of engineering service examinations, and you will get guidelines from experts of subjects. Extraordinary features. Okay. Right. Let us see how many types of subscriptions are there in plus. I mean in terms of duration, and in case of iconic, what will be the cost. You will have 1 month subscription, 30 days subscription, 3 months, 6 months, 1 year, and 2 years. Let's talk about 1 year subscription. In case of 1 year subscription in Unacademy Plus, the fee structure is 25,000. But if you use my referral code GVK10, you will get 10% discount. So the final fee will be 22,500. Very, very affordable. Within 22,500, you are going to meet extraordinary faculty members of the country. My dear students, follow this, share this information to all your well-wishers, friends, juniors, and all members who are aspirants of GATE, IES, or any competitive examination. In case of iconic, the actual fee structure is 45,000. If you use my referral code GVK10, you will get 10% discount. So the final fee will be 40,500. Many features will be there in iconic rather than plus. Okay. Now, these are various payment methods to take subscription either plus or in iconic. Remember, my dear students, GVK10 is my referral code. Right. Let us discuss the session with the Laplace transforms concept. Okay. So mostly tomorrow, by day after tomorrow, Laplace transforms, whole Laplace and inverse Laplace transforms will be completed along with extraordinary previous year problems. Right. Good evening, Hare Krishna. Very good evening. Right. Now, in the last 5 sessions of foundation course, we were talking about Laplace transforms. We have seen Laplace transforms of many functions and many properties we have seen along with some solved problems. Okay. Now, today we are going to discuss convolution product of two functions, and then we will discuss convolution theorem, which is very, very useful in finding the inverse Laplace transform of complicated functions in signal variable S. Okay. So first let me define what is convolution product. So let us see. Suppose we have two functions f of t comma g of t. Let f of t comma g of t be two functions in time variable t. Then convolution product of f of t comma g of t is denoted and defined as f of t star. This star denotes convolution product. It is different from normal product. So f of t star g of t is nothing but integral 0 to small t f of capital T times g of small t minus capital T d capital T, provided the integral exists. Provided the integral exists. So this is the meaning of convolution product. So star denotes convolution product, and make sure about this integral must be a finite expression, provided the integral exists. అంటే దాని అర్థం ఏంటంటే మీరు మీ ఇష్టం వచ్చిన రెండు ఫంక్షన్స్ తీసుకున్నా ఆ ఇంటిగ్రల్ ఎక్స్ప్రెషన్ అనేది రావచ్చు రాకపోవచ్చు, మే ఆర్ మే నాట్ బి. సో ఫర్ దోస్ ఫంక్షన్స్ దిస్ ఇంటిగ్రల్ గివ్స్ ఫైనైట్ ఎక్స్ప్రెషన్. In that case only, I am going to define convolution product. So star defines convolution product. Here you can easily observe. Here we were doing integration with respect to capital T. So inside this integral, small t is a constant expression, and we are going to perform an integration with respect to capital T. Okay. So let us see how convolution products looks like in case of two functions f of t and g of t. Once we get it, we will discuss Laplace transform of that, and we establish a connection between Laplace transform of f of t star g of t in terms of Laplace of f of t and Laplace of g of t. Okay, let's see. I think this point is very clear. My dear students, any doubt? Point is clear. Let us take an example. Suppose I will take f of t equal to e power 3t, g of t equal to e power 5t. Now let us discuss its convolution product at first. F of t star g of t. So let me write out definition at first. Integral 0 to small t f of t dot g of small t minus capital T dt. If you have any confusion with the small t and capital T, replace capital T by, you can have some general expression x, no issues. Anyhow, final result మీకు small t లోనే వస్తుంది. Okay, because limits are from 0 to t. ఇది simplify చేద్దాం. So this is integral 0 to t. F of capital T is e power 3 capital T. G of small t minus capital T. What is g of t? E power 5 small t. ఈ t ప్లేస్ లో స్మాల్ t మైనస్ క్యాపిటల్ T రాయండి. సో యూ విల్ గెట్ e పవర్ 5 into small t minus capital T. So this is e power 5 into small t minus capital T dt. Now inside this integral, small t is a constant expression. So you can write e power 5t before the integral. E power 5t into integral 0 to small t e power 3 capital T into e power minus 5 capital T dt. So this is e power 5t into integral 0 to small t e power minus 2t dt. So this is e power 5t into its integral expression is e power minus 2t divided by minus 2. Apply the limits from 0 to small t. I think this point is clear. Calculation is very clear. So therefore, in this case, so the previous expression becomes what it is, previous one, e power 5t into e power minus 2t by minus 2. Limits are from 0 to small t. So we can write like this. This is a minus half into e power 5 small t. So e power, replace capital T by its upper limit small t. E power minus 0, 1. So this is minus half into e power 3t plus half into e power 5t. So I can write like this. This is half into e power 5t minus e power 3t. Now this is the Laplace transform of, this is f of t star g of t. Now let us find its convolution product. Laplace transform of its convolution product. I think this point is clear. No confusion in this. Very, very clear. Right. So I have got f of t star g of t is half into e power 5t minus e power 3t. Right. Now let us find its Laplace transform. L of f of t star g of t. So this is Laplace of half into e power 5t minus e power 3t. Here you have a minus symbol. You can go for linear property. Constant can be written before Laplace. Half into Laplace of 5t minus half into Laplace of 3t. So you can have this square bracket because half is common for both. So half into Laplace of e power 5t. This is 1 divided by Laplace of e power 8t. 1 by s minus a. ఇక్కడ a value 5 ఉంది. Here Laplace of e power 3t, 1 by s minus a. Here a is 3. 1. So half into 1 by s minus 5 minus 1 by s minus 3. The point is clear. So therefore this is half into, you can simplify this. So this is s minus 3 minus s plus 5 divided by s minus 3 into s minus 5. So 2 gets cancelled. So you will get 1 by s minus 3 into 1 divided by s minus 5. So interestingly, this one is Laplace of e power 3t. This is normal multiplication. This dot is normal multiplication. Dot L of e power 5t. So it means that this is nothing but Laplace of f of t, because f of t is e power 3t, dot Laplace of g of t. So therefore, in this case, my result becomes L of f of t star g of t is going to be L of f of t dot g of t. So this is nothing but convolution product, convolution theorem, and this will be true for all functions whenever the Laplace transform of individual functions exists and the convolution product of those two functions is a valid expression. I think this point is clear. So this statement is called a convolution theorem. So please look at this very deeply. Here I have calculated L of f of t star g of t. This, what is this star? Convolution product. Now here we have got one dot. This is normal product. I think the reference is clear to all my dear students. So therefore, L of f of t star g of t is L of f of t dot L of g of t. This is nothing but statement of convolution theorem. So let me write out this. Next, I am going to write one theorem, that is convolution theorem. So the statement is this: L of f of t star g of t is nothing but Laplace of f of t dot Laplace of g of t. This is nothing but convolution theorem. I think this point is clear. Sir, in what way this is going to help us? In what way this is going to help us? I will discuss within few minutes. If time doesn't permit, anyhow tomorrow I will discuss, because I'm going to start inverse Laplace transforms shortly. So particularly in case of inverse Laplace transforms, they will ask you very frequently inverse Laplace transform of a function in the signal variable. If that function is flexible to apply partial fractions, your job becomes very simple. If that is not flexible, then the only alternative we have is convolution theorem. The only alternative we have is convolution theorem. Let us start with inverse Laplace transforms. I think the point is clear. Inverse Laplace transforms. Right. Let us have some close connection between Laplace and inverse Laplace transforms. You know about differentiation and integration. When d by dx of some function is g of x, then integral of your result must be equal to your question. The same thing happens. Once you have strong expectation in Laplace transforms, it will be very simple to crack any question based on inverse Laplace transforms. Let us see. Suppose you have a function f of t. So when a function is given in terms of small t, you will get its Laplace transform in terms of the variable s. Now it is reverse way. So if a function t లో ఇస్తే మీరు Laplace find out చేయాలి. If a function is given in terms of time variable, we are supposed to expect result in terms of signal variable. Now let us discuss in the reverse direction. If a function is given in terms of signal variable, you need to find a function in terms of time variable. What does it mean is, for what function this is Laplace transform. That's the point. So let me write out a simple definition you can understand very easily. If Laplace of small f of t equal to capital F of s, then I will take this L to the right side so that it becomes L inverse. This is inverse Laplace operator. So inverse Laplace transform of capital F of S is nothing but small f of t. I think this point is very clear. L inverse of capital F of S is small f of t. Let us have some basic formulae. So let us see first one. L inverse of 1 divided by S minus A. For what function 1 by S minus A is Laplace transform e power at? What is L inverse of 1 by S? Previous problem extension. A value is 0 right? First problem. So e power 0, you will get 1. Yes, we discuss L inverse of small a into capital F of S plus or minus b into capital G of S. Here a and b are any constants. Here capital F of S is Laplace transform of small f of t, and capital G of S is Laplace transform of G of t. I think notations are very clear. So therefore here constants can be taken before L inverse operators. A into L inverse of f of S. If it is plus, you write. If it is minus, you write minus. B times L inverse of G of S. For all constants A comma B. This is called linear property. Already we have seen linear property in case of Laplace transforms. Very, very effective this. Most of the problems, if you handle by partial fractions, in case if it is possible, so very frequent model in the examination is finding inverse Laplace transform of a function of signal variable. If that function is very flexible to apply partial fractions on it, your job is very simple. If you are unable to apply partial fractions, in that case, the only alternative is convolution theorem. Anyhow, I will tell you. I think this is clear. Next, so what is L inverse of A divided by S square plus A square sine AT? L inverse of S divided by S square plus A square. So this is cos AT. Now L inverse of A divided by S square minus A square. This is sine hyperbolic AT. L inverse of S divided by S square minus AT. This is cos hyperbolic AT. L inverse of 1 divided by S power n. Can anybody say the answer to this? L inverse of 1 divided by S power n. L inverse of 1 divided by S power n. You know the power of denominator lo S ki powers unnai. You know Laplace of t power n is nothing but gamma of n plus 1 divided by S power n plus 1. So therefore, I am going to write like this. This is L inverse of 1 divided by S power n minus 1 plus 1. But here in the numerator, you have gamma of n plus 1. Here it is only 1. So I can go by like this. Divide with this point, 1 divided by. So this is gamma of n plus 1 into L inverse of gamma of n plus 1 divided by S power n plus 1. So therefore, this is nothing but L inverse of gamma of n plus 1 divided by S power n plus 1. Ikkada n and n minus 1 undi. So I have a small correction here. So therefore here I am going to write like this. This is gamma of n minus 1 plus 1 divided by s power n minus 1 plus 1 . So here divide with the same expression. So this is gamma of n. So 1 divided by gamma of n into this is L inverse of this one. So in place of n you have n minus 1. So I can have directly write this. This one is, you can directly write this point. I'm pointing out this. This is very clear. If you assume this n minus 1 as n, you can easily understand. So this is nothing but t power n minus 1. So this is t power n minus 1 divided by gamma of n. Is this point clear, my dear students? Is my point clear? Any confusion in this? No issues. So it is a t power n minus 1 divided by gamma of n. T power n minus 1 divided by gamma of n. So gamma of n means you can write it as n minus 1 factorial if it is positive value. If it is a fractional value, you can evaluate by using gamma of n plus 1 is n times gamma of n. Got this point? Very clear? Yes. Any confusion in this? No doubt at all. So simple expression, Laplace of t power n is gamma of n plus 1 by s power n plus 1. ఇక్కడ పవర్ లో మీకు n ఉందండి, దాని n minus 1 plus 1 గా రాయండి. So you should get in the denominator, you should have the same expression. So gamma of n minus 1 plus 1 means gamma of n. So this is nothing but t power n minus 1. Laplace of t power n minus 1. So therefore you will get this expression. Next, suppose I want inverse Laplace transform of 1 divided by s into s plus 1. How can you handle this? L inverse of 1 divided by s into s plus 1. How to handle this? L inverse of 1 divided by s into s plus 1. So you can do this by using partial fractions, or you can apply convolution theorem. Here you can see 1 by s times 1 by s plus 1. Here you have a dot symbol. So let's go through previous one. Here we have, if you have either plus or minus symbol, you can go for splitting. But in this case, you have a dot symbol. So by somehow, if you manage to replace dot by either plus or minus, your job becomes very simple. So you can use convolution theorem or by partial fractions. So tomorrow we are going to discuss inverse Laplace transforms by using partial fractions. If that is not possible for few functions, we can handle by convolution theorem. So tomorrow and day after tomorrow, we have a big festival in inverse Laplace transforms. We are going to discuss inverse Laplace transform by using partial fractions. Very, very, very important, my dear students. So don't forget to inform to all of your friends. Inverse Laplace transforms is very, very important. So tomorrow we are going to discuss finding inverse Laplace transforms using partial fractions, using convolution theorem, and moreover we are going to solve linear differential equations with the constant coefficients using inverse Laplace transforms. Tomorrow and day after tomorrow, half an hour session. Very, very, very important. Never miss the class. Okay, just wait for 1 minute. This is official Creatrix channel where you can find 10K plus members. This is our Telegram channel in which you can get links of our live classes every day and notes in PDF format every day we are sharing. I hope everyone is going through that. And these are India's #1 studies channels running by Unacademy. That's why I said earlier this is the best one. Thank you guys. Thanks a lot for bearing me since last 30 minutes. See you tomorrow. Good night. Good night all of you.